diverse features from like biosignals. So here we're going to employ the noise filtering with tactics such as EMD and feature selection with genetic algorithms that have indicated that some of the EGG signal features can classify between healthy and diabetic populations successfully. So here we're going to actually extract features from like healthy people, and then we also extract features from diabetic people and then compare them and know, is this one likely to like have diabetes or like to detect diabetes in early stages. So the objective of our work is to extract features from EGG signals from health individuals and subjects with diabetes, select useful and highly informative features for the diagnosis of diabetes. And we are aimed to evaluate the correlation between the selected features and the process of digestion in both groups of individuals. Next. So what is our problem statement? What are we solving? Right now, diabetes, diabetes, their diagnosis methods are invasive and cannot be continued to monitor like physiology changes, like how like someone, the physical features of a person, like we are only relying on blood as for now. So, and we are facing technical challenges to leverage the EGG signals. So, and these include like high noise level, and ultra low frequency components that demand a robust pre-processing. And another like technical challenge we are facing is high dimensional feature extraction that must be reduced to a set of informative descriptors. And also there is need for classification systems that will and with high accuracy discriminate between the healthy and the diabetic EGG signals. Next. So, what are some of the technical definitions are we going to be using in this? One of them is electrogastrography. It's a non-invasive technique used to measure the record of gastric myoelectrical activity associated with the process of digestion. And another one is electrogastrogram. These are actually the recordings of the electrical signals originating from the stomach muscles. And then next we have diabetes itself. It's a metabolic disorder characterized by abnormal glucose levels. And then also we are going to be using words like feature extraction. It's a technique used to extract useful information that is hidden in biosignals. Next. And what have we come up with? What is our proposed solution? The methodology proposed actually in this paper that we are presenting follows a process. And the first one is the EMD. It's a method used for decomposing and filtering the EGG signals. This one removes frequencies below 1 CPM. And then the next step is like feature extraction. We extract like 30 features from each of the EGG recording based on the descriptive statistics, entropy measures, and fractal dimensions. And then the next step, now we've extracted, now we have to select, we are employing a genetic algorithm, select the most informative features. We choose and relate strongly to the mobility of a signal, like we select according to what exactly we are looking for. If we are looking for like the diabetic people and we already know who are the health ones, so we have a goal, we know what you're looking for, so we can compare these features and we know this is not okay, this one is okay. And then lastly, we classify from the selected feature set into a healthy or diabetic. The subject can use we are going to use like machine learning, and this is going to allow the improvement in diagnosis with possibility and non-invasive and continuous monitoring of gastric activity. Thank you.
Yeah, thank you very much. So I'm going to start from where she has left off, and I'm going to start with the dataset description. So according to the problem descriptions that are given from above, we're working with EGG, and so we're going to look for datasets that have EGG, and then we have the diabetic datasets as well on the other hand. So we combine the two to come up with a probable dataset that can help us train the model to be able to predict the diabetes. Yeah, so for our dataset, we have 100 EGG recordings, including 50 healthy and 49 diabetic subjects recorded using three electron system placed on the abdomen, on the stomach, if I may say, having a length of 10 minutes. So they recorded this for over 10 minutes of all those patients to know the difference. Then the processing of data provides the feature metrics, compromising of time domain, frequency domain, and factor feature. So what we're looking for in this, we're looking for metric. Well, we're working with matrices that have time relatives. So we're working with time, amplitude, and frequencies. So working with stuff like that. Since when we talk about EGG, we're talking about pulses that have different wavelengths, if I may say wavelengths. So sometimes they might be high, sometimes they might be low, depending on whether someone has, on the different aspects. For example, for this case, whether someone has diabetes or not. This data set serves as a foundation for the training and validation of the color classification model, the one that we're going to create. And next, the key findings from this and the expected outcomes. Key findings, then we're looking for the effective feature extraction from the EGGs that we work on from the different data sets we have. We're looking for effective features that will help us study the differences between a healthy and the diabetic subject using the EGGs, or the features that we extracted from those EGGs, for example, the amplitudes, the frequencies, and stuff like that. Then factor dimension and spectral entropy were identified as significant features correlating with the EGG signal mobility. Then the genetic algorithm feature selection. Here we use the genetic algorithm to successfully select 20 highly informative features. So from all those, the 30 that we used before from the EGG, we choose the highly effective, the ones that will work accurately for the data, for the model we are training to reduce the noise and all that. Non-invasive diagnostic potential. EGG-based signals and what to expect. EGG-based signals provide processing signal processing demonstrates the potential of non-invasive and continuous monitoring of the diabetic conditions, addressing the limitations and traditions of the diagnostic methods. So the old methods, by the time you might know that you're diabetic, it might be too late. So these ones, they do consistently track your health and might tell you and might inform you way before it gets worse. Then effective classification are primarily the machine learning models showed promising results in classifying subjects and helping based on selected EGG features, suggesting feasibility. But now we're planning to make ours more effective by using by narrowing down the features that we use to reduce on the noise so that we make the model more accurate. Then the expected outcomes, we expect to improve the diagnostic accuracy using the machine learning framework The machine learning framework is expected to achieve high classification accuracy by utilizing the selected features. Then generalized data sets. Generalization of large data sets. As more EEG data is collected, the model's robustness and accuracy is expected to improve. So as we train it on more data, because we have like 5 different data sets, clustered. So we'll be training it on different data sets with the intention to be more accurate every step of the way. So another thing we expect is early detection of the diabetes, and that is I think the main point. We expect to diagnose someone earlier, even before it gets worse. So then real-time monitoring, with further development, the model can support continuous real-time monitoring of gastric activities in the diabetic management. So even for those that are sick, we expect to help them by continuously assessing their performance in the EGG section. So the conclusion will focus on extracting features from the EGG signals of the healthy individuals and the diabetic, as she said before, to identify informative features, the ones that will help us differentiate between the two, so that we can at least be able to determine when someone is going to get diabetic or how bad they will get in the nearby future. So that is the whole point of the model that we are trying to create. Then the lastly, these are references we've gotten from which we've gotten the information that at least we based on to get a firm foundation to build our model. Yeah. So first, I think I can read through them. Electrodystography, physiological basis and clinical application in the